Same name, different look. We're going to today this cube has been taken apart and they've been left in the order in which they were taken out. Now we're going to find the volume of each piece. And the order that we're going to do this in is by first finding the area of the base. So we'll find the length first, then the width, and then the height. So following that pattern, the first one has a length of A, a width of A, and a height of A. That makes it A cube. So that's A cube. Then the second one has a length of A, a width of A, and a height of B. So this one would be A square B. The third one has a length of B, a width of A, and a height of A. So that gives us B A square. The third one has a length of A, a width of B, and the height of A. So this one, we're going to name it A B. This has a length of B, a width of A, and a height of B. So this would be named A B square. That's A B square. Next one has a length of A, a width of B, and a height of B. So we'll call this sorry, there's a mistake here. This has a length of A, a width of B, and a height of B. So this should be A B square. While this has a length of B, a width of A, and a height of B. So this is BAB. Now this has a length of B, a width of B, and a height of A. Therefore, this is B square A. And the last one has length B, width B, and height B, which is B cube. So remember, you find the area of the base first, and then you multiply by the height.
To get the volume.
Yes. Now, looking at the names, it appears that we have 8 different types of pieces because each name is different. But then, are they all really different? How can we tell? You can see that this piece and this piece and this piece are actually the same, just different positions.
Of the letters.
Not the letters necessarily, I mean the shapes.
Okay.
Forgetting the names now. Merely looking at the shapes, you can see that this and this are equal. They're the same thing.
Mm-hmm.
They have the same. If I lie this flat,
Mm-hmm.
it is exactly the same as this,
Mm-hmm.
which means that essentially a square b is equal to ba square.
And also equal to ABA.
And also equal to ABA. So the order of the factors doesn't really matter. But however, we cannot say that a square b, we can't say a square b is equal to ab square. Clearly, these shapes are two different shapes. They have two different volumes. And that tells us that you cannot rearrange the exponents. You can only rearrange the letters, keeping in mind that each factor is attached to an exponent and therefore must be rearranged along with the exponent. Now, you can think why a square b and ba square are the same. Imagine your own name. Your name might be David Johnson. So sometimes you would have your name down as David Johnson, but in a list or in your register, for instance, in your class register, your name might come out as Johnson David, with your surname placed before your first name. This doesn't change your name. It's still the same name. Only the order of your names has been changed. Now, I'm going to write an example. I'm going to write an expression that we can try to combine. So, assuming we have 5xy squared plus 3x squared y cubed plus 10x let me say plus 10 y squared x minus 6y x squared y plus 5 y cubed x squared minus 2 x y squared plus 6. So, looking at this expression, we have many terms here. and it looks as if some of them might be the same. Why don't we first write them in the same, why don't we write them so that they are in the same order? That way we can easily tell which terms should be paired together based on their names. Now, the order in which we write them doesn't matter. What matters is consistency. So, if we write xy square, if we write y square x as xy square, we have to make sure that we don't rewrite xy square as yx square. It should all be uniform. That's consistency. And then, like I said, the order doesn't matter, but conventionally they are written in alphabetical order with the highest powers coming first. So, that being said, I can rewrite it as follows. Start by rewriting the terms. So the first term we have is 5xy squared plus 3x squared y cubed. Remember, we're writing in alphabetical order, so x should always come before y. You have to be consistent. Then I can say plus 10. This y squared x will now change to x y squared, which looks like this. Then you have minus. Here we have y x squared y. So rearranging this, we'll have minus 6 x squared first. Then we have y and y. Y times y will give us y squared. Then plus 5 x squared y cubed minus 2 x y squared plus 6. Now, we've written this in alphabetical order, and we can now clearly see which terms are similar. So we can now combine these, and once they've been combined, remember the order, when we're writing out the final expression, the order doesn't matter. But like I said, conventionally, the terms with the highest powers are written first, and of course in alphabetical order. So our final expression should look like this. So we have the final expression as being 8x squared y cubed minus 6x squared y squared plus 13xy squared plus 6. So you can practice combining like terms on your own, following the principles I've shown you.